stack and heap. Do you own them? Question 1. Y is a copy of X. I change Y. What happens to X? X changed. I never touched it. 2 more questions are coming. Explain all 3 and you own it. By the end, you will. To explain that, look inside the variable. Start with the number. A is 5. Copy it and B gets its own 5. Change B and A does not care because they are 2 separate boxes. Now try an array. The array is too big. The box holds an address, an arrow. Copying the variable copies only the arrow. Now 2 arrows point at one array. Your variable is not a box holding a data. It is a node holding directions. Your program runs in 2 rooms, the stack and the heap. The stack is a pile of frames, one per method. Inside sits what you passed, what you made, and the way back. It is fast because making room moves one marker. Calls slide the marker up. Returns slide it down. So the last one in is the first one out. The heap is different. Objects land anywhere. Making one feels cheap. The bill comes later. Each object carries a hidden tag, even the empty ones. Let's answer question 1 inside this map. This is the picture. Your variable sits on the stack. Your data does not. Back to the test. Question 1. The change follows the arrow. Only one arrow exists. So X sees it. That is your bug. Question 2. Y gets a whole new array. Does X change? No, X does not change. This line builds a second array and Y's arrow turns to point there. X arrow never moved, so X still reads the old array. Mutating leaks, but reassigning does not. Now pass the array to a method. It gets its own arrow to the same array. Change the array inside and the caller sees it. Reassign inside and nothing escapes. The frame pops, the arrow dies. Java copies the arrow, never the object. JavaScript and Python do the same. Question 3. Is your private data actually safe? Here is a wallet with a private coins array. But the constructor stored the caller's array. So the caller still holds an arrow. Their edits move your balance. The getter returns the real array. Anyone can reach in. Private protects the field, not the object it points to. The fix is simple. Copy at both doors. Copy what comes in and what goes out. Now the wallet owns its data. The stack does one last thing. It ends. This method calls itself and never stops. So every call adds a frame and nothing pops. Watch the counter. On my machine, it died here. The stack is fast because it is fixed. Fill it and your program dies. Each thread gets its own stack, but they all share one heap. That is why 2 threads can fight over one object. Keep one rule. Copy before you change, or do not change what you did not create. Now you know where your data lives. One question is still open. When an object's last arrow dies, who throws it away? Next time we free the memory. It does not leave. Subscribe and understand the systems you build on.